Okay, can you all hear me okay? I will be speaking in English as advertised, so if anyone has any questions, you can speak to me afterwards in Italian, but the talk I'll give in English. Okay, so this talk is on Haskell in the real world, which is a slightly cheeky title, and I'll explain why. But it does describe a particular problem for an actual real-world problem, and I'm going to try and look at it in Haskell. So I think it'll do what it says on the tin. So first of all, I don't know how much everybody knows about functional programming, but it's often considered quite a different type of programming to what we normally use in Perl, for example, imperative programming or object-oriented, and so on. And one of the great guys in the Perl community, Mark Jason Dominus, in his book High Order Perl, which I know a lot of you will probably have read, or at least skimmed through, Perl actually shares quite a lot of features with Lisp, and not just little things like syntax, which it doesn't really share with Lisp, but first-class functions and various other things which are really quite important. But that's not all that functional programming is about. A lot of it is to do with gluing functions together and writing in a way that's quite declarative, and we'll see some examples of that. So, first of all, popular functional languages, probably the most popular language that exists at all is Excel, which you could argue is really a programming language. But it has functions, it has the possibility of chaining quite complex behaviours and making very complicated calculations, and it's widely used in businesses around the whole world. So you could argue it is the most popular functional programming language, if not programming language, in the world. SQL is a largely functional language, so even if we're not all writing in Haskell, we're actually quite exposed to FP. Matt was just talking about LINQ and data querying, and a lot of this stuff was, which Microsoft uses for its database access, is based on mathematical research into things like monads from Haskell. And then, of course, we've got the more traditional functional languages. So on the one hand, the Lisps and the schemes, and nowadays we have Clojure. And you have the strongly typed languages like the MLs, OCaml, very popular in France and other places, and of course Haskell, which we're going to look at. Or not. It's supposed to work. Interesting. Aha. It looks like I have a very nice blank dumper PDF. Which I just exported. So, I'll open it again. There we go. We have some things there. We know what's going on there. Okay, so Haskell isn't exactly the same as all of those other languages, Excel, Lisp, etc. And one of the features that people often talk about is purity. And the other thing we'll often talk about is laziness. Now, I'm not actually going to talk a lot about laziness in this talk, but we will talk a lot about purity, and we'll kind of see what that means. And the other very interesting thing, which we'll see in hopefully some detail, is the type system. And I'm not going to go into kind of mathematical explanations of Haskell typing, but we'll see how reasoning about problems using types is a very powerful way to solve real-world problems. So all of those features there, so if I were to talk about memory management and category theory and so on, might sound very academic and very dry. But there was a very nice quote about Haskell, when will it go mainstream? and one of the answers was it mostly has. All of the really interesting ideas from functional programming have already entered Perl and Python and .NET. Well, not all of them, but a great deal of them. So here's a nice example from a slightly pseudocode C-like language of doing something with this list of records. And if you programmed any C, you probably will recognize what that's doing. But you may have to stop and think about it and look through each step and work out, it's iterating through a list from 0 till the length of the records, and if the list at the position of that iterator matches O, then we'll add it to another list at the right position. So it's a little bit clumsy, but what it's basically doing is selecting those ones that match O. So it's very simple, but the functional version of it, of course, is 3 lines long, and nothing there is extraneous. You couldn't remove any word, any symbol, without removing the meaning of what you're trying to do there. So why is that version better than that version? And perhaps if you're a die-hard C programmer, you might argue. So just in case, why I think it's better is obviously there's less code. And that means there's less bugs. Now, of course, the pedants, I know you're all Italian, so you probably won't be pedantic about things, but less bugs is wrong. So fewer codes, fewer bugs. But why is that better? In the other one, we declared a variable I for the iterator into the first list. We declared a variable j for an iterator into the second list. And we looked at the length of records. The function isn't about I, j, length of record. They're completely synthetic. They have nothing to do with the problem that we're trying to solve. Another thing in the second one is if we got the plus plus or the plus plus in the wrong place, we put plus plus I instead of I plus plus, we'd have a nice off by 1 error. There's no space in that very short code to have any errors. You basically can't get that wrong, so you eliminate a whole class of problems. You can skim the code and immediately know what you're trying to do. And it's also very clear to the compiler, which means that if the compiler wants to send parts of the job to different distributed systems with Hadoop or Elastic Cloud or whatever, it can do so, because it knows what you're trying to do in the code. In C, how would it be able to tell? I, j, length records. And of course, in Perl, we have grep. So we already have this learning from functional programming. And so do all these other languages. This isn't something that's unique to Perl, or even that Perl is the best traditional language for using. But we do have it. So again, in very simple Haskell, you can chain things like that, which may be clear what that's doing. Word splits up hello there Fred into hello there and Fred. We run a filter, which is like grep, taking the head, the first character, and checking is it uppercase. And then we count how many results did we get. So the answer, of course, is 2 for the capital H and the capital F. So very simply, you can piece together very small functions in a quite Unixy way to get more complicated behavior. So obviously those are fairly basic, very simple, and not especially kind of real-world problem examples. So there are lots of examples instead in a book called Real-World Haskell, which was published a couple of years ago, and it has rather more interesting examples with things like JSON libraries, database connectivity, reading a barcode, actually scanning the GIF image of a barcode, correcting it for rotation and turning it into a list of numbers and so on. So it's got some very interesting projects, and rather than using one of those projects, I recommend you to read the book. It's very clear and well written. I'm going to go to look at a problem that I've actually faced in my job. So, I work for a company that has a learning information system which delivers quizzes. So multiple choice quizzes to people in business to check whether they've understood something that they've been trained in. So this is very real world. It pays my wages, it pays my business partner's wages, and it's written in Perl. So we were trying to design how we would do a certain new feature, and I was thinking this would be much easier in Haskell. So I designed and implemented just that part in Haskell to see how easy it actually would be. So this link will come up again at the end if you're interested. The code's on GitHub, so you can run it and see what it looks like. So this is just really to give a flavour of how I went about solving a particular problem. As a not very good Haskell programmer, either. So it's not full of lots of very clever things. So a quiz is effectively a list of questions with multiple choice answers. So you can choose A, B, or C as the answer to a question. And we might want to divide the quiz up into different sections. So we might have a section on geography and a section on people, for example, famous people. And you can see that might be quite nicely modelled as a tree structure. So you have a section of geography questions and a section of people questions, each of which have got a number of questions. Now, the feature that we wanted to add was to be able to randomise a quiz. So we might be able to want to do that at the level of a section. For example, say we want to have 2 out of 3 questions about geography, and then all of the questions about people. But this was the feature that we wanted to add, and I was having trouble thinking about it in Perl, so we wanted to see how we do it in Haskell. But as well as having the randomization at the level of sections, we thought, wouldn't it be nice if you could also have subsections? So for geography, you could have natural features or buildings, for example. And you could also randomize those subsections to say, I only want to have either questions about buildings or questions about natural features, rivers, mountains, etc. So, just kind of reiterating that, we've got a tree structure which is made up of a quiz which can have sections or not, and the sections could be randomized. And finally, at the bottom of the tree, at the nodes of the tree, you've got the questions that you're going to ask. So, now here's the first bit of Haskell that I'm showing, apart from the toy examples. And it's very similar to what I've just shown you. The quiz node data type can be one of those things. And each of them have got various pieces of information, like the name of the section or the name of the question. Maybe a score, if it's a scored question. And the quizzes and sections will then in turn have more quiz nodes inside them. Obviously, some of these things like name, score, and answer aren't defined in Haskell. So a name is just a string, it's a synonym for a string, and a score and a 2 is just integers. And this is quite nice. Haskell allows you and encourages you to be very expressive with how you define your types. And the answer, in turn, is either a multiple choice or a string choice question. And we'll see examples of those in a second. So the Boolean answer is just a yes-no answer. So here, for example, we can already, just having done the types, we can already declare a whole quiz. So for example, here's a random section about geography, and we've got all the questions about what's the capital of England, capital of Italy, and you can see there we've given Rome or Roma, so you can answer it in both languages. It's actually quite expressive, I think, and fairly easy to read, having done a little bit of work on the types. Okay. And similarly, for the multiple choice ones, we can say which of these people are Beatles. So the top 4 of them, John, Paul, George, Ringo, are, and Bob and Jason aren't. Now, of course, Y and N aren't types, because if we didn't have them, we'd have to write that, which looks a little bit clumsy. But in Haskell, that's easy enough to do. We can just create little functions that will generate those bool answer true and we will answer false, so we can have a nice declarative definition of this quiz. So, we then came to the problem of you have a template for a quiz, and just like in object generation from a class, you want to have the actual quiz that a user will take. So, in this case, we know that the user is supposed to take one section on geography, either on natural features or cities, and they should take 2 questions about people out of 3. But an actual user might then get, and coming to the projector is too low for that, but the user might get assigned just natural features and just questions 1 and 2, for example. And in each case, that will be different, and we want to know which specific questions the user was assigned to. So, I said that in Haskell, a large part of your thinking is about what types things are. So, if we looked at this function, we would be calling it stamp. We would be taking a quiz node, because a quiz is an object of type quiz node, and at the end of it, we'll have something that looks very similar. So I'm going to pretend at the moment that we're going to get a quiz node at the end of it, and we'll see what happens. But first of all, a parenthesis about functions. So this is what I mean by the types. A function called increment goes from a number to a number. So for example, increment of 4, which is a number, gives you the result of 5, because it's, which is still a number. Okay. And that's how you define it in Haskell. And in general, all you can do within a function is act on the things that you've passed into it and on any variables that have already been declared in a different scope. But, because it's a pure language, though that's variable, it can't actually vary once you've started the program. So if x is 42, then this add x will always add 42 to the number that you pass in. So there's a whole load of stuff that actually you can't do in a Haskell function. For example, you can't, I'm simplifying here and I'll come back to it, you can't do reading and writing from the disk. You can't check what time it is. You can't throw, you can't generate a random number, and you can't speak to the internet, because functions have to give the same result every time you call them with the same parameters. So, when we look at the stamping problem again, we've got to get a random number in order to go from this quiz node to this other quiz node. And of course, I just said...
sorry, excuse me. Can you repeat if I understood well? With Haskell, you can save, you can't interact with internet?
You can, but not purely functional.
Yes.
It's hidden. It's a bit hidden.
We'll come to that, because it's an interesting fact that if you look at the definition of a purely functional language, it appears at first sight that all of those things, random numbers, time, and so on, you can't actually deal with. And given that I've actually said that one of my major cases is I want to be able to handle random numbers, we have to get around this. So
that's the whole point of Haskell, that functional languages before couldn't handle that way, but Haskell found a way how to handle these things well, even if you have functional programming on the other side. So you can do it.
Okay.
Thank you.
So, in this case, of course, this would be impossible, but there's a way around it, which is monads, as I've already mentioned. And I'm not going to go into monads in any great detail, because all I want to do here is to show that we can deal with real-world problems in Haskell. So, because we have this other component of input and output, i.e. random numbers, we're actually returning something called an I/O quiz node. So we're extending the type with some of these capabilities, effectively. And monads are basically a data structure. They were discovered by mathematicians, and they have some applications in logic And the theory of them isn't too hard to understand, but it is quite confusing if you're not from that background. So there are lots of tutorials about monads, and it's often said that the easiest way to understand monads is to write another tutorial, which then nobody else will understand. But using them is actually very easy, and we'll see some examples of it, and that's the, I think, most important thing to take away. So, the first thing we'll do is just have a look at, for each of these types of quiz node that we had, how do you go about stamping them into the particular thing that the user is going to be looking at. So, for a question, for example, it's very simple, because a question is just a question, and that will get returned exactly as is. For a random number for a random section, we'll actually generate our random number, choose which of the questions or which of the subsections to use, and then return just a normal section node, which is no longer random. It's actually already decided which of the child elements have been chosen. And yeah, that's another example of the same thing. And of course, a section will just return itself, or rather it will return the stamped version of itself. So if its child elements in turn are random, then they'll have to get processed. So it's very much a kind of recursive tree operation. And the same is valid for the quiz. The quiz is stamped by stamping all of its sub-elements. This might seem a bit theoretical, so we'll actually look at some code briefly. So the very simple example I gave of a question is it's returned unchanged. So to stamp a quiz node that is a question, just return the question. Then, to stamp the quiz, return all of its child elements stamped. And the same is true for the section thing. Now, this is how you'd actually do a tree processing in Haskell. Map the stamp function on all of the child nodes. And as you can see there, I've actually got a couple of other things like this funny dollar in brackets and an M at the end of the map. And effectively, because we're having to use I/O to deal with random numbers, we're forced to use a slightly different function. So, as you can see, in this particular case, in order to get random numbers, we've got to add 4 characters to some code. So it's not a whole load of stuff. You have to know how to use it, but it's not too difficult. Of course, the really interesting case is the random one, where we'll call another function, pickN, which will actually do the rolling of this random number, choosing which children we pick. And then at the end of it, we'll return a new section exactly the same way as we would have done a section. So, I said before that types were quite important in Haskell, and it's often said that you can tell a lot in good Haskell code by looking at the name of a function and the type signature. So, for example, if we do if we look at take node, this is basically the function to take a quiz. It takes a quiz or a section or a question and returns a completed version of that. And so we can think, well, it's got I/O there. So what could I/O possibly mean here? It could involve things like the user typing their response, or interacting with the web browser to choose their response. And it could also involve printing back to the user saying, yes, your answer was correct, or incorrect, or whatever. So similarly, this one here, print question, doesn't give a value. That's what that blank, the empty parentheses means. But it does start from a quiz node, and it uses I/O. So obviously what that's doing is it's printing data to the user. For example, which of these 4 people were in the beacons is an I/O action from the question definition. And then we have other help functions to show multiple choice questions, and finally to check the answer. So taking a string of user inputs and the correct answer, we can return a true or false value. And even though that says check answer, you'll notice that there's no I/O in the type signature. So that's actually a pure function. So even though we're doing user inputs and user outputs, in Haskell we try as much as possible to have pure functions behind the scenes and then some routine that will actually tie them together with user input and output. So just as an example of a very important routine that does use input and output, just to prove that it is actually possible in Haskell, after having worried you by saying it was impossible. Here's how it works. We print a question on a node, we call getLine, which takes a line of inputs. We check the answer with that line of input that we just got, and then at the end we tell the user correct or wrong and return a completed node. So if you look at that, you can probably imagine how you'd write it in Perl, and it's actually very similar. You're doing getLine, you're doing print, you're doing all the things that you would do in a normal programming language, and without a whole load of extra complications. So though I was sort of trying to, in a way, tease by claiming that I/O was impossible in Haskell, it's actually not as hard as can be made out. So, and at the end of it, the sample program that I wrote to test this is effectively that function. So taking a quiz, we stamp it, and we pass it to the function and take a quiz. And that's all that the main function is. And I think it's quite interesting that as opposed to a Perl script or a Java module, it's not just an entry point, it is actually genuinely a function which is made up of other functions. And I think that's quite a nice distinction. Now, I was hoping to give you a live demo, but I'm not going to, sorry. That's because Matt's kindly lent me his computer, but I didn't have time to install Haskell and all kinds of other things on it. So I can show you on my Mac later if anyone is interested. So of course the question is, should you all be programming in Haskell? And I have a confession to make. Though I prototyped that particular problem in Haskell, and I think it worked very well, I'm not actually using that in production code. We wrote that functionality in Perl as well. We have tens of thousands of lines of working code that pays our wages, and my business partner didn't want me to take the next year off rewriting Haskell. I can't imagine why. But if I had a new project, I think it would be quite fun to do it in Haskell. And here are some reasons why you should go for Haskell. It is very powerful. It's also actually not, surprisingly, it's quite fast. So one of the things people say is it can be faster than C. Obviously you have to find the exact code for which it is faster than C. And the compilers are always improving. And yeah, sometimes you'll strike lucky and some people run very, very fast. But if you write things in a naive way, sometimes you may find that code will be slow, and because it's very different to Perl code, C code that you might be familiar with, it can be hard to optimize it and get it to a really nice speed. This is the one place that I mentioned laziness, that you can often get away without doing a lot of work in Haskell because values will only be calculated when you need them. And that can be quite nice because you can write very naive code and it will actually run quite fast because it doesn't bother calculating things that you ended up not needing. As a general rule, if you look at shootout code, for example, C will be the fastest thing. The scripting languages, Perl, PHP, Python will be the slowest thing. Java will be somewhere in the middle, and Haskell will be somewhere around Java. So sometimes it's faster, sometimes it's slower. So it's certainly fast enough for most things, and it's a perfectly capable language. Of course, the question is, are there jobs? So I'm in the northwest of UK. I've never seen a Haskell job advertised in the northwest of UK. I don't know what the situation is like in Italy, and I've been told there are some Haskell programs here, so I'll ask afterwards. In fact, are there Haskell jobs?
not that I know of.
Okay, so not that we know of. That's a shame. Libraries and tools, hidden under there. There's the Haskell platform and Hackage and Cabal. These are kind of the equivalents of CPAN. And there are a growing number of libraries, some of which are very well designed and of quite good quality. There are, I think, nothing like the number of libraries that exist on CPAN yet, but the situation is always improving. So you may well find that someone has already tackled something that you want to solve. Of course, should you learn Haskell is a very different question to should you immediately become a Haskell programmer. And I think you should, or at least I'd recommend people to, because it is very powerful and it's very interesting. So it makes you think about problems in a very different way. And having looked at Haskell and programmed with types and thought more about how am I joining up my functions, what kind of inputs and outputs are they making, I think that's improved my abilities as a Perl programmer and as a designer of code. So I think it's a very valuable thing to do.
Every time I try to learn, I came up with this one meta thought that made me help understand Haskell, and I wondered if you agree with it, is that with Haskell, you don't tell the computer what to do, you describe the problem and let it figure out how to write the program for you.
Okay, so Inge has just said that he's found that Haskell programming can be quite declarative. Rather than telling the computer what to do, you'll describe the problem and have it figure out the answer for you.
Or have it figure out the program for you.
Figure out the program for you, yes.
Right.
I find that up to a point, yes. It's not a logic programming language as such, though it has extensions for doing that. But yes, often having described a data structure and transformations on that, you'll find that a program will seem to kind of fall out of that design process very much. There's lots of talk about how functional programming techniques are the next big thing. Part of the reason being that processor speeds aren't increasing as fast as they used to, whereas the number of cores are, opportunities for parallelization are always increasing. So a lot of the opportunities to use purely functional code that doesn't mutate state and is therefore easier to parallelize are always going to be useful. So I think learning these techniques will be useful in the future. And it might even be that your language, Perl or whatever else, is taking on a lot of these capabilities. So it may be that none of us program Haskell in 10 years, but I think we'll all have benefited from the research that has come out of Haskell.
Thank you. I think another reason why I use Haskell or other functional programming languages is because systems nowadays get bigger and bigger and more crafty. If you write it more in functional language, you abstract your programs more and more, and so your software tends to be less crafty and slimmer, which is a good thing. Okay.
So Herbert is suggesting that writing in a functional style will make programs less crafty and slimmer. I wonder whether in a large Haskell code base you don't accumulate craft in exactly the same way as in a large Perl code base. But I hope to some point have the opportunity to find out whether that is the case or not. But yes, it's probably likely. Because of the fact that you have to specifically tell Haskell that you want to use I/O or you want to be able to use these kinds of values in a function, there are fewer opportunities to make crafty functions that know too much about the wrong thing and so on. So I imagine it does reduce craft.
No, just because of the fact it's for people who can think very abstractly, and so you can abstract every function way to the most abstract possible way, so you don't have least duplication in your software.
Yes, and that's a very interesting point about abstracting away problems. One of the things that people say, the Haskell programmers say, is that instead of just abstracting over particular functions, they will abstract over whole design patterns. So for example, monads make things like input and output and software transactional memory or command line applications all be part of the same kind of structure. So they've abstracted over much larger units of behavior than just a single function. So that's quite interesting and fascinating, and it also makes your head hurt. But it's very interesting. So we have 5 more minutes. So that's the talk done. So if anyone has any questions in English or Italian, or yeah. Thank you.
What's the big, in your experience with hanging out with these dudes on the, you did a lot of IRC?
Yeah.
And where did people seem like they were actually doing Haskell for work? Where in the world was it a hotbed of it?
People tend to be doing work in banks. So I think in London and the States.
Was there any specific banks that were like?
Specific ones, yes. And if you go to the Haskell wiki, there's a page on Haskell jobs or Haskell companies. Jane Street Capital is the big one that uses not just Haskell. I think they use a lot of OCaml and FP Technologies. And I know there are other banks. I don't remember which ones now. Obviously, because a lot of people interested in Haskell tend to be PhD mathematicians, and they tend to be quite clever. One of the problems with coming from a not academic Perl programming background is that you don't necessarily feel clever enough to compete with these guys. So for the very few Haskell jobs that do exist. And I think one possible solution to that would be to create a Haskell startup in your local area, maybe as a side project. And this is something that I fully intend to do once I have copious free time to do it. Okay, thank you very much.
Does it support large numbers? And how much large numbers?
I don't know. But,
As large as they fit in memory.
there you go. As large as they fit in memory.
Okay. And what about can be faster than C? How much faster can be?
It depends on the problem.
And on luck.
There was a project to do super compilation, which I think isn't in the main compiler GHC, but they found that there were certain classes of problems that would compile faster than C. If we program in Perl, the fact of it being slower than C isn't necessarily a problem, because we're already programming in a language that isn't as fast as C.
The thing why it's sometimes faster than C is, of course, C is always faster, but certain problems you don't. If you have complex programs, you don't understand the old program. You just divide it in some problems and then solve problem for problem. And because Haskell understands the problem in the whole, it can optimize in ways you normally wouldn't understand. And that's why in the end it gets faster. But because of mathematical reasons, not because it can write faster codes.
Okay.
Yeah, that's a very good point. That the optimizations are on a much higher level than possible in C. Which is the same thing as with the grep versus the very imperative code. The compiler doesn't know what the code is doing in the C case, but it does for Haskell.
And does it support recursion?
Yes.
It's built on a code.
Yes. Absolutely. Yeah.
They do loops with recursion.
Yeah. So, yeah. Fully tail
It
call
doesn't
eliminated.
support not doing recursion. You can only do recursion. I'm just kidding, but yeah, everything is recursive in Haskell.
Mostly because it's the obvious way of doing it.
And if I write a program in Haskell with MapReduce, I can make it run on a lot of computers, and I gain for free MapReduce, or I need some more representation.
Yeah, there are probably libraries to do that. To say that Haskell is capable of supporting MapReduce isn't to say that it necessarily has backends that currently do that. Probably somebody has written a PhD on it, and it will exist as a research project. I don't know whether they're robust and used yet.
This is actually another reason that learning some Haskell is really useful, which is lots of very interesting research into separating state and functionality is getting implemented in Haskell now. So if you want to look at the cutting edge of, say, functional reactive programmer, which is absolutely fascinating, you are not going to understand the papers unless you understand at least a bit of Haskell. I mean, I could not write a complete working program in Haskell, but I can read it well enough. And being able to read it has been a huge advantage for me in terms of being able to read research.
Yes, that's a good point. That Haskell is a lingua franca now for academic papers on computer science. So yeah, that's a really good point.
For me, it's in the same category as Lisp. Most of the time, I don't get to use this in the real world, but learning it has made me a better programmer, and being able to read it gives me the opportunity to tap into lots of extra stuff.
And now let's tap into the configuration.
Yes.